So welcome everybody. Thanks all for joining and tuning in. Today is our third session and every Friday we meet at the same time, and this is to talk about the different aspects of MLOps. I know it's a very unique field which is emerging right now. Think of it as how would you take machine learning machine learning algorithms and actually build them to production. What are the different things or different aspects that you have to think about? So, this is all the knowledge that I've gathered, and I'm going to be putting them in short snippets and sharing them with you. As with every single time, if you have questions, please do leave them in the chat, or whenever I do a post, please leave your questions so that I can get to them towards the end. Today, we already have a few queued up questions, so we will get to them. So last class or last session, we looked at data pipelines. I even shared some code as to how you would go about curating good quality data, right? So that is just the first aspect. Today, we are going to look into the kind of ML variants, MLOps variants, specifically for ML pipelines. So let's get started. First, let's get into some key terminology, because I'm going to be using these terminologies a lot. So it's important that we understand them before we keep throwing them out there. So let's look at what a typical ML production system component looks like. And you've seen this picture many times. If you follow the live streams that I do, this is a very common figure that you will see in different shapes, formats, and sizes. And again, every single session, we will start from here so that we understand where or which part of the module or which part of the block we're actually looking at. So as I mentioned last time, the first part always is the data pipeline. So data pipelines typically is an asynchronous process where you're collecting data, and then you're ensuring that it is high quality, it has high signal to noise ratio, or PSNR, and all of those metrics that I shared. Again, if you couldn't find it, please, I will be linking the playlist in the description box below. Please check out the previous video so that you find more continuity here. So we've already looked at the data pipeline last time. And as I mentioned, typically the data pipeline is an asynchronous process. So if I'm a large organization and I have data, but I want to create machine learning products, the first thing I would do is find a data labeling company and outsource this work so that they can give me batches of good annotated data, because they already have this data pipeline set within the company in order to do that, right? So typically data pipeline is an asynchronous process. Then the second most important part that comes in is the model pipeline. So model pipeline is where you iterate through different iterations of different kinds of models. So if you're looking at computer vision, you could have fast RCN, faster RCN, masked RCN, and it completely depends if you're looking at single shot models, or if you're looking at two shot models, or if you're doing semantic segmentation, if it's UNet versus fully connected, the fully convolutional neural networks. So all of these are different variants, and this is where you are actually playing with the current batch of data and updating your model. And finally, the most important and the key piece, it is the deployment pipeline. And this is actually where most of the gap in the industry exists. When I say gap, by that I mean typically when we have machine learning engineers, they do a demo, right? So you can have a Flask and Fast API, and it's an API call which is exposed. But you will rarely see somebody who has Dockerized it, put it on a Kubernetes cluster, and made it work. So that is the gap that we are trying to bridge, because typically DevOps people are supposed to take that responsibility of taking something which is an exposed API and putting that into something which is a production module. So that's the bridge that we are trying to make, so that ML people can also do the ops part, and the production can actually come out in a seamless fashion. Now let's look at a typical AWS blueprint. So this is actually an image by AWS, and let's understand what the CI/CD pipeline is. So you will hear this word multiple number of times. CI/CD means continuous integration, continuous deployment, or continuous delivery. And again, if you want to really know about these terms, I'm going to link two videos in the description box below. They are by IBM Cloud, and they really give a very good definition of what CI and CD is. So think of it this way: you are a developer, right? So, but you're not solo. You have, you're a group of machine learning engineers, and you're committing code to a repository. Ideally, it's not GitHub in a company, because GitHub is too open. It's public. They use GitLab, or you can have your Google repositories, or or Azure repositories in each and every one of them. So you commit the code. whenever you do commit the code, there has to be a building service. So this is services. Typically, it can be Jenkins or something that does CI. What CI does is it makes sure that you have multiple people when they are committing code. They are not, first of all, they're not the differences of them are resolved. So it's not multiple people rewriting on the same, or if somebody is deleting, then there is a good rollback point, right? So the CI maintains a good readability and a continuity to a particular flow. And then the building service also takes care, if you're now think about a Docker. So if you have machine learning algorithm, if you have a service API, if you need to Dockerize it, so then that Docker, creating those Docker containers would be a part of that build. So when you build the process, and then there is this, it is ready for deployment. So a Dockerized container typically is considered to be deployment ready. You can put it in a Kubernetes cluster or just keep it running, right? So there are some companies who just work on Docker, like PayPal. And then there are some companies that actually do Kubernetes orchestration, such as Bose, right? So all of the Bose products. So completely depends on what is the business case here. And then once your deployment service is ready, again, this is completely your infrastructure as a service. It could be any of the cloud platforms. So, you have GCP, or you have AWS, you have Azure, whatever it is. And then it goes through a staging process. So the staging process is, it's going to make sure that your application is ready to be fed to the client. Now, the staging process becomes super useful whenever you are trying to do versions of the same model. So let's say that, like I was talking about, is let's say you have semantic segmentation problem, and you started with unit, but then you're seeing unit is actually not giving you the best results. You ideally need fully convolutional neural networks in order to do that. Would you all of a sudden stop the Docker container and then add a new Docker container and let your clients have it? That's actually not the best way of doing it. So that's the reason why you come up with these YAML files, the YAML files or the YML files. What they will do is they will ensure that some amount of traffic can actually go to this new update, while some amount of traffic goes to the previous format. There is some amount of unit testing. And after that, if it gets good outcomes from the unit testing, only then it is pushed out to the consumer. So this can be actually done in the Kubernetes cluster orchestration. There's this Anthos service mesh, there's this Istio service mesh. All of these, they help so that you can keep doing this continuous delivery. So if you think about it, continuous integration was happening up into the first three parts, actually up until 0.4, and then continuous delivery is actually happening in the latter half of this figure. So this is the whole thing, and this is just a snapshot in AWS. You can do the same thing in Azure. You can do it, in any of the other service platforms as well. If you have any questions, please leave them on the chat. Before I leave, I'm going to be answering as many as I can. Now let's look at the MLOps type. So this is where most of the question in around the industry remains, is everybody hears this word MLOps and they think it's one thing, but that's not actually true. It also has, like machine learning algorithms, like computer vision algorithms, there are some that are easy, there are moderate, medium, and then there are some that are hard. So MLOps also has variants. The first of all, you can talk about the MLOps pipelines, and this can be somewhere between easy to medium, the difficulty level. And here you actually have flexibility on pipeline creation. That means you can have flexibility on what kind of resources you want to use. Do you want to use infrastructure as a service such as Terraform or not? Do you want to stick to something like MLflow, Airflow, or can your pipeline, does it really, how often do you need canary releases? So all of those, whenever you're getting into the pipeline creation, you're sort of more on the dev side. You're still not on the production side as much. So that's the reason why you still have some flexibility on the pipeline creation. And typically, even in large organizations, each and every one of these pipelines, they start as asynchronous. They are not all sync, they're not all working in sync. First of all, like I said, the data pipeline. Typically, large organization will always outsource that work. Then there's a model pipeline. So you will have a team of ML engineers who are already constantly creating these models, and then they are exposing the API calls, and then maybe Dockerizing it as well. And then there is a deployment. So there is this difference between exposing an API call and deploying it. So deploying it, again, SageMaker is an excellent example of doing that. what a deployed model, and again, a deployed model doesn't mean that it has to have a front end and everything. A deployed model, all it means is you can make a call using an HTTP URL and then just say that URL.predict, and it'll tell you what the prediction for this new test case is. So it's just that the deployment and monitoring pipeline, just setting that up, can sometimes be pretty intricate in itself. So Kubeflow pipelines is another example where once the Kubeflow finishes, it will expose a deployment endpoint. And then there is monitoring as well. So monitoring means, so if you've ever gone to the larger organizations, and if you look at their delivery or the rollout teams, they will always have these huge screens with dashboards on them. And these dashboards are essentially telling them how many people from every single country or how many regions they are actually logging in, how they are interacting with your web app, and how they are proceeding. Are they going to the next page or not, and all of that. So monitoring is a huge element of all of this. And typically this is a skill which is less understood by machine learning engineers. So that's the reason why typically this task of deployment monitoring is generally taken by DevOps people, but it doesn't have to. That's what we are trying to say. And then finally comes to the automation, where you try to automate all of this together. So like I mentioned, the data pipeline is typically a asynchronous, model pipeline is asynchronous, deployment monitoring is asynchronous. Whenever you try to automate all of them together, then that is the automation pipeline that we're talking about. Let's take some examples in order to better register what we're talking about. So Vertex AI by GCP, it's actually a great way in order to set up data pipelines, so annotations, and you keep getting batches of data. There's label box, there is label image, there's so many different tools and services out there. Mechanical Turks, AWS is another way. Model pipeline, again, the different model versions based off of the use case, like I just mentioned, if it's unit versus fully convolutional, or if maybe you're going from semantic segmentation to bounding box. So in that case, what are the steps that you do in order to make sure that you're going from one model version to the other? Then comes your modeling, deployment and monitoring pipeline. So here it's the Docker versus Kubernetes, and for monitoring, typically the standards, the industry standards are Prometheus and Grafana dashboards. And in the automation pipeline, this is where you must have heard these terms, OTC, over the air, so OTAs, over the air updates. So over the air updates typically would mean that you have one version and then you want to release another version. And then these are typically called canary builds. A Kubernetes orchestration is very good at doing that. And then you can further automate it just using your tag. So let's say you already have a repository, and you have, whenever you commit code to a repository, you always tag it. So as an update one or something like that. Even if you commit code to GitHub, you will see you always provide comments in the bottom. So whenever you tag code, you can actually start a Spinnaker pipeline where it will take the code, it will generate the Docker file, it will ensure the Docker can then go through your CD, your continuous deployment. So Jenkins is another tool that is used for it. And Kubeflow pipeline is extremely useful in order to continuously build ML models so that your CI/CD pipeline can go seamlessly. Now, again, I say it's easy to medium. The first few, keeping everything asynchronous is easy. Syncing everything up is the medium difficulty. And then comes the hard or the difficult task, which is the ML in production. And here, the flexibility in pipeline resources is much smaller. So here, what you really want to do is take everything and automate the process so that everything works like a well-oiled machine. You have data, you have the model continuously being spit out, you have the deployment continuously happening, and then everything is just going out. So the customer is constantly getting fed with updates. It doesn't even realize there is no downtime. And the app just keeps getting better and better and better. So in this case, what we're talking about is complete automation of every individual pipeline with automated CI/CD. And it could be so automated that as soon as you do a code commit, a Docker build is started, then there's a Docker push, and then you do your Cloud Run or Kubernetes deployment. Now, I will say that learning the first part, or the MLOps pipelines, is still possible. And if you do your individual learning, and it's more software engineering and up to a certain extent. But ML in production is actually hard and that's because every single, and there are very few companies that have this complete automation in process. And the main reason for that is, they don't have the need for it. So some companies just do data engineering, some companies just do data labeling. There are very few companies that actually have a need to do everything together. And that's the reason why there are actually very few ML in production, actual use cases in the industry today. So let me just quickly show you some of the examples of the different difficulty levels that I was just talking to you about. So this image is actually from the Google. So if you just Google, and I'm going to be linking this in the description box below. So this is MLOps by Google, and they have shown the different difficulty levels. So this is level 0, like I mentioned. So you have some amount of data analysis, you're doing some amount of data pipeline, you're doing some proof of concept. This is your ML model, you're doing some manual experimentation. And then let's say you have a trained model. So let's say you have a unit model here. What you would do is then you would Dockerize it. As soon as you have a Docker container, you push it to a model registry. You can have a model registry in GCP. There is a model registry in AWS. Every single one of the cloud providers have that. As you see, it says that this is offline. So this whole process is happening offline. You push it to the model registry, and then you are ready to serve it, right? So you can do a Kubernetes orchestration, or you just do a GCR, so Google Cloud Run, and then that's just going to be serving the model. And this is just doing prediction. So this is the very easy or level 0, which is very achievable if you start studying in this particular direction. Then comes the difficult part. So just going from level 0 to level 1 is actually hard. And here what you see is things now are getting synchronous. And this is where the challenge arrives, because now it is multiple teams working together in cohesion. So think about it as if you're doing this data, so this is the data pipeline, right? So everything you're doing with your data pipeline along with your model evaluation and everything. So all of the source code is going to a source repository. So you have multiple people, they're committing code to a, let's say to a GitHub. And then there is this deployment pipeline, and this pipeline deployment, this is where you're looking at Spinnaker or Jenkins, some way in which you're doing CI/CD. And then after that, in the back end, there is always some amount of feature extraction that you're doing. So because if you're constantly going to be synchronizing your data pulling as well as modeling as well as your deployment, you have to always constantly keep storing the data as well, right? So storage retrieval is equally important. So that's why some amount of feature engineering, finding metadata, storing the data away in a compressed format so that you can quickly retrieve it, all of this becomes super important then. And then again, so you're extracting batches from a particular feature store, you're doing your data validation and your model training and everything. And again, every single time, whenever a Docker is created, you're pushing it again to your registry. It's again in a train pipeline, and then you're doing a CD model serving, right? And just as the CD model serving is done, the client is getting access to the updated version. So ideally, Kubernetes is the best solution for it because it does canary builds seamlessly. What that means is if you have a version 1, you have a version 2, as soon as you're creating the Docker files, it will automatically start rolling out, but it will happen in a very seamless fashion. So all customers will not see the same rolled out version at the same time. They will slowly start seeing as more and more people start using it, you will see that the change has been pushed out. So that's the reason why Kubernetes becomes super useful whenever you are talking at level 1. And again, here another key area is the model performance. So having those dashboards, because it's super important to understand what are those metrics that you're really looking for so that you would know that it is working versus it is not, right? So that's the reason why monitoring becomes super important. And as you see, there are trigger points that are telling you now trigger this, now trigger this. So ideally these trigger points could as well be code commit, or it could just be that a new Docker has been received in the cloud. So these are the few triggering modules in a CI/CD pipeline. And finally comes to level 2, which is what I'm calling is MLOps in production, which is one of the hardest ones, where everything happens in unison. It's like the data team is extracting the data, giving the code. There is automatically a pipeline that will ingest and generate an endpoint. Automatically, as soon as that endpoint gets generated, a Docker container will pop up. That Docker will then automatically, using your canary, will be pushed to Kubernetes, and the customer will never see a downtime. They will never face that the system is down or 404 error, or none of that will happen. And again, if there are anomalies, or if there are some metrics that you're monitoring, that let's say you're doing bounding boxes, and all of a sudden you start getting confidence scores are like 0.5, 0.6, 0.5, but it's never going to 0.9 and 0.8 what you're expecting. So in that case, you understand that there is a need for retraining. So monitoring will tell you this. So in that case, you have to extract data, and then you have to again retrain the process. So this has to happen continuously. And in such cases, typically, whenever you're looking at huge amount of data which is coming in every single day, think about Twitter or any place that has these feeds where your feeds just coming in regularly, and you're trying to understand this, is it sentiment analysis, is it accurate or not, should we flag it? So in systems like that, monitoring has become super important, so that you can flag or retrain your model to modify. So essentially what I'm trying to say is MLOps level 0 and 1 are definitely achievable. 2 is very hard, and very few industries actually do it. Now let's look into the ML model pipeline. So we have looked into the whole system, and now we're just looking at what are the different components of a ML model pipeline. So think about it. I'm part of a large organization, and there's already some amount of past data, which is already stored and annotated and labeled. What my job as an ML team would be is to process the data. So again, there has to be some amount of automation in this processing as well, because if it's the very similar kind of data, and every single time you're spending 70% of your day trying to clean data, you're really not making much progress, right? So there has to be a certain amount of automation in cleaning. So there's a lot of softwares that's out there, like Trifecta is one of them. It takes CSV files, and you can actually start putting rules without even have to write one line of code. It will automatically generate these rules for you, and these rules will say, so if a particular column is not a number, remove it, or if there are two columns that are very similar to one another, that means correlated features, remove them. So it will automatically take care of these things, and you can generate these rules very quickly. So data processing and cleaning, there are certain softwares and systems to do that. Now, once you have your CSV file, or if you have your clean data, then you should start with your predictive data model. And then whenever your model is predicting something, you always should think about as online monitoring parameters and offline parameters. And I've talked about what the differences between them is. An online or live parameter is something that you don't need a ground truth. You don't need the actual result for it. So some examples of online parameters are probabilities, right? So if you're or if it's a bounding box, what's the confidence score to it? So these are all examples of online parameters. And then offline parameters is, again, if you take a batch and if you get ground truth, you just, so anything like accuracy, F1 score, precision recall, all of them become your offline parameters. And this process actually continues, because there has to be some amount of hyperparameterization, there has to be some amount of model selection, which one should you pick. And sometimes this feedback can also be guided by the business case. For instance, let's say that your goal was cyst segmentation in medical images, and you pass the UNet, but then the specialists or the doctors are saying that no, these regions are not accurate. In that case, you might say that, okay, let me try something which more complexity or more parameters, but it might be giving you a more accurate result. So in that case, your choice might just be to go with a fully convolutional network, right? So you could do that as well. So sometimes it is also guided by business case. And putting everything together, you are actually a part of your ML model pipeline. And sometimes this model feedback also helps in new data generation. So it's not working. If the doctor is saying that no, these regions are not accurate, you might say, okay, can you tell me what are the good images, and then get them annotated. And that's where your new data creation can happen. And most of these times you always have to do A/B testing. And again, there are so many ways of doing A/B testing. Canary is one way in which the same two different population of people, they are interacting, but they don't know. So one of them actually get the actual model, and the something is running in the shadow in the background, so that the customer is not getting access to the rolled out version. And once it meets all of the unit checks, only then the shadow version is released. So there are shadow deployments, there is A/B testing. So there are varying kinds of orchestrations for feedback that can be done with Kubernetes as well. All right, so now that we've covered all of that, let's look at a typical example. And this is actually answering one of the questions that was asked about concept and model drift, and how do you actually answer that. So let's take a use case, right? So let's say that you have data from a store A and you're training an ML model and you get, your beta testing is showing that, it is predicting who wants what. So think about it as your Target app or your Walmart app or anything in which that's telling you, these are your recommended products, do you want to shop for this as well or not? So, and, you've trained on Target and you're testing on Target, it's great. Now, let's say you add a new store like Safeway, and you are not retraining, you just have test data, you take the app as is, and now you're serving it to the customers, but the customers are not happy. I mean, maybe they're looking for milk and they're, you're showing them diapers or something like that. It's absolutely unrelated. So in these cases, what typically happens is you have to understand, or the questions that you need to ask, what to do when a model underperforms on new test data. Something has gone off. I need to monitor something and I need to do something. Now, what are these two things that you need to do? And this is where ML monitoring comes into play. So there are these two things called data drift versus concept drift. A data drift means there's a change in the underlying data distribution. So like I said, so you've already trained on data from Target, but now for Safeway, it just might be that the way the aisles are organized or the way the inventory happens. Like Target, it carries clothes, it carries cosmetics, it carries like a huge range. But Safeway is more for groceries, right? For food. So definitely there is a change in data distributions, right? So because of which the same model that worked for Target is not now going to scale for Safeway. And then there is the concept drift, which is the change in the input to the output relationships. So the same feature, so even, and I'm just making this up, so maybe it was the barcode or the QR code and, the cost. And these were the features that you were using in order to predict if this should be recommended. But now, if you're looking at complete groceries and a whole range of groceries, and the same cost can happen to a grocery product as well as to a clothing line. But both are so different that the input to output relationships now should have changed, right? So that's the reason why in these cases you should look for data drift. In which case, if you are monitoring, let's say for Target, you were getting something curves that look like this, and then for Safeway, now you start getting recommendations, or your confidences are very low. So in that case, you will know that for this particular data set, you definitely have to retrain. It's not going to be feasible by just having the current model rolled out. And then again, for concept drift, the same, ideally in this question that I said, Target versus Safeway, the answer is you have both. You have data drift as well as concept drift. So definitely you have to retrain. Sometimes if there is only data drift, if you can scale and make some adjustments in the underlying data distributions to make it similar to the previous one, you won't need to do a complete model retraining. But if there is concept drift, model has to be retrained. Otherwise, you're not going to get good results. So these are some of the things that an ML pipeline person has to be wary of, so that they are always spitting out the right models required. And finally, I wanted to talk about the ML in production. So I think this is one of the questions that was asked. What are the important components if you're looking at the fully automated, where everything is synchronous? What are the different components there? So in a large organization, let's say, where we are doing ML in production, the first and the most important team is data engineering. And data engineering, what they do is, of course, they curate, they ensure there is fast storage and retrieval. They also find metadata. They know how to tag each and every data stream that is coming in. They do some amount of feature engineering so that you understand what features are useful, what are not. So throw away the data which is not useful, data cleaning, and fast storage retrieval. So they're always doing this very synchronously so that good data is available for the machine learning engineers thereafter. Then there is an ML model pipeline automation. So the deployment, doing that continuously. And this is where Kubeflow pipelines with SageMaker or TensorFlow Hub deployments are extremely useful. So Google's Vertex AI is able to do that. Amazon SageMaker is also able to do that with Kubeflow pipeline automations. Online monitoring, as I mentioned, could not stress more. This is huge importance on the online monitoring of these metrics, as well as the health of the ML app. So that's the reason why whenever you do Kubernetes orchestration, there's the health of the pods that's constantly monitored, so that that at any time if a pod has gone wrong, you have to change it or give a new pod. Then there is ML versioning. So if it was the first version now, is there a new Dockerized version? So there is unit testing. How would you want to roll it out? Do you want to do it in a shadow version? Do you want to do it in a canary version? So do you want to do an A/B testing first? So all these components have to be designed so that the right ML model is being pushed out. And finally, most importantly, is there is flagging, there is ticket filing and resolution system. So typically what I've seen is larger organizations, they take care of this as a separate entity. So, and these are a little more offline activities than being synchronous. So by flagging, I mean, and this could definitely be the testing team, or based off of the feedback that you're getting from clients that they are not happy with the outcome, or something has changed, or of course they won't say system is down, but even if they do that, there has to be a way in which so typically what it becomes, this becomes a ticketing system. So if it could be something like a ServiceNow, where you start a ticket, you raise, this is your concern. Some of the companies such as Cisco are also working on fully automating this process of ticketing, so that they can put a metadata around it and say, okay, which division should be handling service requests or something like this. So a fully ticketed resolution system is the way of giving feedback to the ML model that it's not working for this data set, maybe change it, or the business case should say that it doesn't work for data sets such as this. So that would be our topic for today.